So we are going to do this chapter. All right, so let's do a little bit of recap first. Okay, water exists in 3 states, right? So we have the solid state, liquid state, as well as gaseous state, or you can call it the gas state. Okay, now, so when water change from one state to another, okay, it actually gain or lose heat. Am I right to say that? Yeah. So are you familiar with this? For example, let's talk about liquid water. So liquid water, okay, if it were to change state to, let's say, solid, what do you think happened? Does it gain heat or lose heat? When liquid water changes to a solid,
it loses heat.
it loses heat. That's right, it loses heat. Okay, and what is that process known as?
Freezing.
Freezing. Okay, at what temperature does it take place? 0. Caleb says
Degrees Celsius.
0. Okay, 0 degrees Celsius. And what do we call this temperature? What do we call this temperature? Caleb,
Melting point.
is it the melting point? Not exactly wrong, but when it's liquid changing to solid, right? When it's liquid, freezing, yeah. But the freezing point and the melting point, they are actually the same, you know it, right? Okay, so very quickly, so let's go through. So if you see my screen, right, I start with solid ice, okay, and then there's liquid water, and there is gas, water vapor, 3 states of water. Okay, so melting at 0 degrees Celsius, when it's a change of state from solid to liquid, there is a gain of heat. Okay, and then from liquid water to gas, right? So there is also a gain of heat, and then this is known as boiling at 100 degrees Celsius, or we call it evaporation at any temperature. The opposite happens as well. So gas can be converted to liquid. We call this condensation. Heat is lost. Okay. Then you also have water changing to ice. We call it freezing at 0 degrees Celsius. Heat is also lost. Okay, so Caleb, you're not wrong to say that it's melting point, because melting point and freezing point will be the same. Okay, yeah, melting point and freezing point will be the same. Can I go on? Okay, you already know this very well, right? Okay, good. So next thing, I want to highlight on condensation, when there is a change from gaseous state to liquid state. Okay, so when liquid boils, right, sometimes you see the mist, isn't it? You see the mist just in the area above that pot of water, for example. So above that boiling water, you see something like cloud, something like mist, okay? Mirrors also become fogged up, right? During warm showers. Okay, a glass of cold drink, okay, when it's left on the table, on the floor, okay, or on the kitchen top, we'll have water droplets forming on the outer surface of the glass. Right now. Okay, we don't say that the glass of cold drink is sweating, right? Cannot be. It's because condensation took place. Why is that so? Condensation occurs when the warm water vapor, there's a lot of water vapor in the environment. When the warm water vapor comes into contact with a cooler surface, the cooler surface can be the outer surface of the cold drink. It can be the mirror, okay, the surface of the mirror, okay? So it loses heat and then changes to water droplets. Okay, very important thing is talk about the warmer water vapor coming into contact with cooler surface. Okay, and then loses heat. So the warm water vapor loses heat and changes to water droplets. This is known as condensation. Are you clear on this? Yes, good. So all these terms are important. Why do I want to highlight this today? Is because I want you to know when I mark students' scripts, I always see that they missed out certain words. Okay, things like loses heat. Most of the time, students will say that, water vapor comes into contact with cooler surface and change to water droplets. They forgot about losing heat. So these words here, just 2 words, will cost them 1 mark, right? So the cost is very, very high. Be very careful. You don't want to lose marks that way. So I want you to take note from now on, always talk about the loss of heat. Can? Good. So tell me, what are the factors that affect the rate of evaporation of water? Okay, Caleb and Kenny want to answer that. Kenny, you want to answer that? Oh, the one, huh? Okay, Caleb, come.
Amount of wind.
Okay, amount of wind. Can you elaborate a little bit?
Like there's a fan blowing the water.
Okay, give me 1 minute. I put my marker in. Need to do this connection. Okay, good. So you talk about the amount of wind. Okay, can you repeat what you said earlier?
Like there's a fan blowing the water, so the rate of evaporation will be higher.
Be higher. Okay. The wind, let's say there's wind, right? Now my camera is so good. Okay, good. Now, so when there is wind, when there's more wind, right? What happens? Okay, the wind actually blow away the water vapor formed, right? So on top of the surface, let's say is a one bowl. Just said I can see you there. You're trying to annotate it. Okay, there's one bowl. Let's say there's one bowl of water, right? The top surface of the water in the bowl will start evaporating, right? It converts to water vapor. When the wind blows, the wind will blow away the water vapor form and allows more space for other water vapor to be formed. Clear? That's why the rate of evaporation increases. Okay. So allows more space for more water vapor to be formed. Okay. So that is one. What else? What other factors? Amount of wind is one. Wei-Le, try another one.
The amount of exposed surface.
Okay. Exposed surface area. So the greater the exposed surface area, the greater rate of evaporation. Good. So I'm not going to elaborate that. I think that one quite easy, right? Okay. Next one. Vinuli. Temperature of surroundings. Okay, good. So The higher the temperature of surrounding, the greater the rate of evaporation. True? Any more? Is there any more factors that you know? Jason, do you know any? Jason, your camera disappeared.
Not really. Not really.
Okay, one more. I add on one extra, okay? Humidity of the surroundings. Did your teacher go through this with you? Yeah, so actually there are 4 factors. In your textbook, only 3. It wasn't mentioned on the humidity. However, we know that it can affect the rate of evaporation. So let's say, okay, what do you understand by humidity first? What do you understand by humidity? Swastika?
Like the amount of water or sweetness.
The amount of water vapor around us. Is Singapore humid?
Yes.
Yes. Okay, how many of you early in the morning, let's say you shower before you go to school, okay? Then after you take the shower, right, and then you get out of the house, okay, let's say you walk to school or walk to the bus stop. How many of you already start feeling sticky and you're perspiring? Yeah, same thing for me. Okay, even when you are walking from school back home, right? Okay, it's not just the hot sun that affects you. It is your perspiration as well and the stickiness you feel. So the stickiness is not just due to your own perspiration, it's also because of the water vapor in the air, okay, that actually condenses, let's say, and form on your skin. So you feel very sticky. So the humidity in the air can affect evaporation. The more humid it is, okay, the more humid it is, the more water vapor there is in the air. So thereby it will affect the rate of evaporation. Okay, evaporation is slower. The drier the environment, the faster the rate of evaporation. Is that clear? Okay, so let's go on to the questions now. When water is cooled to 0 degrees Celsius, what will happen?
It will freeze.
It will freeze. Okay, is that all? It will freeze. Yeah. Do you think it will gain heat? Do you think when water is being cooled to 0 degrees Celsius, will it gain heat, Vinoli? No, it doesn't, right? Okay, will it evaporate? Will it change from liquid to solid state? Yes. Okay, so this is correct. Answer is A. Next, condensation. Condensation takes place when, let's see who I want to call upon. Tati. Tati, what is your answer? Jason, turn on your camera. Tati, I cannot hear you.